So, dear students, once again we'll start with differential equation. The last topic in our this syllabus of differential equation is linear differential equation with constant coefficient. Now we have to understand what is this linear differential equation. See, linear differential equation, when we say, the meaning is the form of dy by dx. This is first order differential, dy by dx plus py is equals to q. Dy by dx is first, that is why it is called linear. If it is d2 by dx square, it's non-linear. So those differential equation we have to study in graduation or engineering. So linear differential equation with constant coefficient. Constant coefficient means the coefficient of dy by dx, that is always to be a constant. We don't want here any variable, correct? If it is constant, that also we have to remove. So that is why it is mentioned linear differential equation with constant coefficient. The form is dy by dx plus py equals to q, where this is in fact first form. We have various forms in linear differential equation. We have to discuss only two forms in our syllabus, where p and q are functions of x or constants, or functions of x you can say, or constants, right? Means this differential equation is in the form of dy by dx plus py equals to q, where p and q are functions of x or constants. Let's say if I'll write one problem, look at this. Dy by dx is equal to xy. In fact, you write here plus dy by dx plus, wait, this I'll write plus here. So dy by dx plus xy is equals to x squared. So look at this here. Here p is going to be x and q is x squared, correct? Then only we can compare this dy by dx plus py equals to q, correct, to this equation. So whenever such form, see, you cannot do here variable separable as well as, and you won't have a homogeneity type also. Neither you can go any substitution. So this type of equation is known as linear differential equation with constant coefficient, or you can say directly linear differential equation, L dot E, correct? Linear differential equation. Since dy by dx is linear, one it is their order, so it is linear. So this p and q you came to know. Now what we have to do in this form? Why linear differential equation, and what is the solution of the linear differential equation? See here, once we came to know this dy by dx plus py equals to q, where p and q are functions of x or constants. So we'll talk about now the solution of this differential equation. That is what important, because equation is given, we have to find solution. So as I told you that we are not able to use in this equation directly variable separable as well as homogeneity also, it doesn't look, because dy dx equals to x square minus xy it will come. So what is the next? So first we have to understand this is in the form of LDE, linear differential equation. We came to know p is x and q is x square. So its solution is designed here. What happens? There are steps. First step is to get a solution of such differential equation. First step is we have to calculate integrating factor, which is e to the power p dx. P dx, p is your x here. Now the question is, what is the advantage of this integrating factor to this differential equation? See, what happens when you go for integration, this factor will help you to integrate. That is what straight away we can say integrating factor. These factors help you to get the solution of this type of differential equation. So first we have to always calculate integrating factor, which is nothing but e to the power integral p dx. Fine. Suppose for this equation we have e to the power p is x, so x dx we can say. Now what is the integration here? E to the power x square by 2. No need to write c here. It's just e to the power x square by 2. This came integrating factor for this particular sum here. This sum we are drilling. Now next step is, second step is important here. Its solution is ready-made here. Its solution is ready-made in the sense that you have to remember. Like which way? So it is in the form of dy dx plus xy equals to x square. In fact, p y equals to q. So its solution is y into integrating factor is equals to q into integrating factor into dx, because p and q are functions of x or constant you can say. So these two steps that you have to remember. First, for in linear differential equation, you have to calculate integrating factor, which is e to the power integral p dx, correct? And now its solution is ready-made also, which is y into integrating factor is equals to integral q into if into dx. So once we came to know this solution is in this form, already you have calculated integrating factor. So multiply here y into e to the power x square is equal to q is your x square. So x square, and then integrating factor is e to the power it's x square by 2. E to the power x square by 2 into dx. Now we will integrate this much, and whatever the integration it will come, that is going to be the solution of our this differential equation, correct? So linear differential equation, how we will solve? We'll have two steps. First, calculate integrating factor, but you have to just compare what is your in your question, whether it is in this form dy by dx plus py equals to q, where p and q are functions of x, then only we have to proceed these two steps. Now we have another form also. There we'll discuss what are the things we have to remember. So first form dy dx equals to py equals to q, where p and q are functions of x, or you can say constant. First we have to get integrating factor, fine, and then its solution y. See, the py it is, so you have to take here y into integrating factor is equals to q into integrating factor and into dx. Once you have integrating factor, substitute this, and finally you integrate this one, you will get the solution. So this is what our first form of linear differential equation. Now we'll discuss the second form of the linear differential equation, because both the form is important in board as well as in your NDA exam. Now we'll see the second form. Second form of a linear differential equation is dx upon dy plus px is equals to q. Look at the change. Dx upon dy plus px equals to q, where p and q are functions of y. P and q are functions of y or constants. It can be constants also, correct? So this is our second form, dx upon dy. The previous form was dy by dx plus py equals to q, where p and q are functions of x or constants. In second form, look at this here, it is dy by dx plus py equals to q. Second form is dx upon dy plus px equals to q, where p and q are functions of y, or you can say constants. So if you want to note a couple of examples, like let's say dx upon dy plus xy equals to y square, if it is. So look at here p is y and q is y square, correct? And dx upon dy as well. So this is in the form of our second differential equation form, which is dx upon dy plus px equals to q. Clear? Now, here also we have two steps. First, same as in the first form, get integrating factor. Here integrating factor will be, there it is e to the power p dy. Here it is e to the power p dx, dy, p dy, because p is a function of y. See, e to the power integral p dy, correct? This is our integrating factor. And second part, which is its solution part, and its solution is x into if. In the previous one it is y into if. X into if integral q into if into dy, because p and q are functions of y. See, in the previous form we have solution is y into if, q into if into dx, because p and q are functions of x, correct? For this form, dy dx plus py equals to q. In second form, it is dx upon dy plus px equals to q, where p and q are functions of y. So e to the power p dy is integrating factor. So q into integrating factor into dy, correct? So in both the forms, one thing it is common, that you have to calculate integrating factor. And second is solution, you have to remember for this form y into if, correct, into q into if dx. And for the second form, x into if is equals to integral of q into if dy. Fine. So in these both the form, what will happen, the question when it comes, what you will come to know that neither variable separable will help you nor homogeneity will work. So the third case is even substitution also it won't work. So then we will take a call that this differential equation is in the form of linear differential equation. And then we have to compare both these two forms. One of the form will be that question, and then we will proceed what we have discussed in these two forms. Calculate if and then its solution. Clear here? So I believe these two forms you understood. It's like already, it's a format, it is there in both the form. It's a format. In fact, they told us the steps how to get the solution. Get integrating factor and solution, it is ready-made, that you have to remember. Same way in the second form, get integrating factor and its solution is also ready-made, that you have to remember. Q into if into integral of qif into dy. Find here. And the role of integrating factor is, again I would say that it will help you to get the solution. That is why integrating factor we say. So these two forms in this linear differential equation, we have some more form. In fact, one form, it is familiar to 11th 12th student, but it is not there in your 12th as well as in NDA, which is known as Bernoulli's differential equation. This is there in JEE Mains, Bernoulli's differential equation. This form is also there. This is also a part of differential equation. We have various parts, but these two you have to do. This third one is there in for JEE Mains. Those students who are preparing for JEE Main, they know what is Bernoulli's differential equation, correct? So in the linear differential equation, these three topic it is there, and out of these three, we have to do these two only. First one dy by dx, second one dx by dy, px equals to q. Find here. So in some books you will find Bernoulli's differential equation also. If somebody got the problem, let me know. I will tell you how to solve it. But right now it is not necessary to discuss about Bernoulli's. All forms are very simple, but you do these two only. If unfortunately some student they got the problem of Bernoulli's, let me know. I'll definitely tell you how to solve this. Now we'll discuss the problems based on linear differential equation with constant coefficients. Correct? So the first question I'm taking, solve, means find the solution. Dy by dx plus y is equal to e to the power minus x. Now first of all, while looking the question, we have to start with whether we can go variable separable. No, it's not possible, because y, if you take this side, it becomes minus y, and then it won't be, you can't separate. So variable separable fails. What about homogeneity? Of course, there is no question of homogeneity, because e to the power minus x, and this is y, so it is non-homogeneous. In fact, we don't talk about homogeneity part also. Third is substitution. Again, there is no hope for substitution also, because substitution we require some x plus y or xy term so that we can substitute. So substitution also fails here. So out of these three methods, what we came to know till in differential equation, we are not able to, get the solution with those three methods. So now the fourth form, which we came to know right away, that linear differential equation with constant coefficients. So in this, this is dy by dx plus py equals to q, where p and q are functions of x. P and q are functions of x or constants. Functions of x or constants. Correct? So look at here. Here p, what we can say, 1. P is 1 here. What about q? Q is e to the power minus x. Fine. Functions of x or constant. So it's true. P1 and q e to the power minus x. So what is the first step to get integrating factor? Integrating factor, which is e to the power integral p dx. For this form, dy dx plus py equals to q. For this form, integrating factor is e to the power integral p dx. Now, e to the power integral 1 is p, so e to the power dx, which is nothing but e to the power x. Integration of dx is x. So if is confirmed, which is e to the power x. Do not take c here. Write only e to the power x. Now its solution, which is ready-made with us, its solution y into if. Correct? I'm writing formula here. Q into if into dx. This is the formula from which we can get the solution. If we got e to the power x. So y into e to the power x. Q we have e to the power minus x. If we have e to the power x into dx. So now what left? E to the power minus x into e to the power x becomes 1. So dx left, and dx is x plus c. Integration of dx is x plus c. So final solution we have y into e to the power x equals to x plus c. This is the required solution of the given differential equation. Dy by dx plus y equals to e to the power minus x. Fine. So we compared with our linear differential equation with constant coefficient. Correct? You get this? We compared with this equation where we came to know p and q. then integrating factor e to the power x, then its solution y into if into q into if integral into dx. We substituted the value of integrating factor, which came e to the power q is e to the power minus x and e to our x, so it becomes dx. Integration of dx is x, so y ex equals to x plus c is the required solution of this differential equation. Fine dear, I believe all of you understood this format. Sometimes in NDA they ask only integrating factor, so that way also you can calculate. They will ask one differential equation it is given, and they will ask, the question is find integrating factor. So you have to just compare with those two forms of linear differential equation. If it is this form, so integrating factor is this one, correct? If it is dx upon dy, the integrating factor is e to the power p dy. Now we'll move to our next problem. Look at this. See, what is one more important thing is here, look at this, the coefficient of differential equation is free from coefficient. We don't want any coefficient here. Actually, we don't want any variable here, correct? If it is some constant also, that also you have to eliminate. That you take care, because down the line we'll see couple of sum where we will have to eliminate the constant or variable. Now I'm talking, we'll take the another question. See, this another question is x sine x dy by dx plus x cos x plus sin x into y is equals to sin x. This is what a differential equation. Now we have to find the solution of this differential equation. Find solution of this differential equation. So again we have to compare. This is x sin x. So if we remove this x sin x from here, how we can remove? We have to divide. So then it will come dy dx plus py equals to q, where p and q are functions of x. So first we have to divide by x sin x. क्या करना होगा डियर? पहले हमें x sin x से दोनों साइड आप डिवाइड करेंगे, तो हमारे पास ऐसा कुछ रह जाएगा, x cos x sin x upon x sin x into y is equals to, I believe 1 by x will left, correct? X sin x से divide करोगे तो 1 by x. Understood? So now this came into which form? dy by dx plus py equals to q, where p and q are functions of x. दिख भी रहा है अपने को. यहाँ पे मैं p क्या लूँ? p is x cos x by x sin x को आप लिख लो cot x प्लस sin x कैंसिल, तो ये 1 by x आ गया. ये हमारा p है. And what about q? And q is 1 by x. Both are functions of x. और ये y है py. ठीक है. So now this form came, dy dx first form. So what are the steps? First we have to calculate integrating factor. Integrating factor in this form we know e to the power integral p dx. So e to the power integral cot x plus 1 by x into dx. अब इंटीग्रेट कर लें कि पावर के ऊपर सबको. cot x का इंटीग्रेशन हो जाएगा डियर log sin x, फाइन, प्लस 1 by x का इंटीग्रेशन हो जाएगा log x. तो इस टोटल को आप e to the power log x sin x भी लिख सकते हो, since log m plus log n is log m into n. And all of you know e to the power log x, e to the power log x is x. ठीक है, ये हमें log की प्रॉपर्टी में पता है. e to the power log x is x. So मैं यहाँ से डियर इंटीग्रेटिंग फैक्टर क्या मैं फाइनली लिख सकता हूँ, x sin x. Clear? This is our integrating factor, because e to the power log x sin x came and e to the power log x is x. So integrating factor came x sin x. Now its solution also we know ready-made it is. So its solution क्या होना है डियर, y इंटू आई एफ. आई एफ क्या हमारा x sin x इंटीग्रल q is 1 by x into if, which is x sin x into dx. This is what form, y into if is equals to q into if into dx. So from here I believe x get cancelled, sin x dx left. Correct? Now from this side, at the end, xy sin x, and integration of sin x is minus cos x plus c. अब इस cos x को आप इस साइड ले लो तो फाइनल सोल्यूशन जो है हमारा वो हो जाएगा डियर xy sin x plus cos x equals to c. This is the desired solution of the given differential equation, which is x sin x into dy dx plus x cos x plus sin x into y equals to sin x. Go through करें डियर. मीनवाइल मैं जस्ट थोड़ा पानी पीता हूँ जरा. करेक्ट? थोड़ा आप इसको मिडवे में ला देता हूँ जो सबको दिखाई दे. क्वेश्चन दिख रहा है? ठीक. 2 मिनट देखिए, मैं थोड़ा पानी पीता हूँ. हर एक स्टेप को समझिए. आई बिलीव समझ में आ गया है ये क्वेश्चन. फॉर्मेट में कैसे जाना था, पहले तो x sin x से आपको डिवाइड करना है, क्योंकि dy dx के कोफिशिएंट को हमेशा आपने क्या रखना है, फ्री. तो आपने x sin x से बोथ साइड यू डिवाइडेड. तो हमारा फॉर्म आ गया dy dx प्लस py इक्वल्स टू q, वेयर p एंड q you came to know, and then integrating factor. At the end its solution. ठीक है, चलिए डियर, we'll move to our next problem in same linear differential equation with constant coefficient में देखते हैं. Look at the next problem. Next problem I am taking from solve x plus y dy by dx equals to 1. This is very favorite, most, and it's a demanding question in your NDA. Lot of time they have asked this problem, solve this differential equation, and most of the time student they do mistake in this sum. Say again we have to think of all 3 method what we did earlier. We are not able to get here separable variable separable. Second is homogeneity also fails, and substitution is also fails here. Correct? So what I'll do, I'll try to make it our those 2 form. So for this, if we go with dx this side, right, and dy, so what left this side, dx, and we took this side cross multiplication, so this side x plus y. Now look at the form, dx upon dy form might be, it will come. Or what you can write, dx upon dy minus x I am taking here, and y I am keeping this side. As we know the second form, dx upon dy plus py equals to q, px equals to q, where p and q are functions of y. So now we have got this, or constant also, functions of y and constants. So this form, while looking this, we believe that this is going to be our in second form, where p equals to what? See, plus p, x it is there. So p will have -1. And what about q? Q is y. Correct? So we came to know p and q. Now we'll have to go the integrating factor. So we'll find integrating factor here, dear. So integrating factor for this form, you know, e to the power p dy, correct? So this is e to the power minus dy, because p is -1. So this will give you e to the power -y. So integrating factor done here. What integrating factor came? This came e to the power -y. Now we have ready-made solution. What is the solution of such differential equation in second form? So its solution is, there it is y, here it is x into if. If is e to the power -y, correct, is equals to q. Q is here y, and integrating factor is e to the power -y into dy, correct. So this form we observed that this came. Now it is integration, so there we'll use by parts here, dear, correct. Now it is a question of integration only, so this we will use by parts because u into v function. So x into e to the power -y, here we'll use by parts. So e to the power -y is going to be u only, v, and y is u. So go with u into v form, y outside, integration of e to the power -y, dy minus derivative of y with respect to y, so dy by dy, because function is y, and then integration of e to the power -y upon -1, and then we have to integrate total dy. So x into e to the power -y. Now after integrating and simplifying this, we will reach the final answer. What you can see, this is going to be -y into e to the power -y plus e to the power -y plus c, right? So this is going to be the solution of this differential equation, correct. By parts we did here. I believe all of you know by parts, how to integrate u into v rule, u outside v integration minus derivative of u, and then again integration of v, and then again we have to integrate this, so it came this one, okay. So x plus y dy by dx is equals to, का solution ये आ गया dear, फाइन. कैसे कैसे हुआ, हमने पहले इसको स्टैंडर्ड जो अपना लीनियर डिफरेंशियल इक्वेशन है उस फॉर्म में लाया, तो ये हमने dx अपॉन dy हुआ, तभी ये फॉर्म आया. अगर आप dy dx लिखते तो ये 1 अपॉन x प्लस वाई हो जाता और फिर आप कुछ नहीं कर पाते. तो अपने को dx अपॉन dy किया क्रॉस मल्टीप्लिकेशन से, ये फॉर्म दिखा, यहाँ से p और q हमने कैलकुलेट किया, फिर उस फॉर्म में हमें पता है इंटीग्रेटिव फैक्टर e टू द पावर p dy होती है, e टू द पावर माइनस dy, ठीक है, इंटीग्रल, this came e to the power -y, and then we have ready-made solution which is x into if integral q into if dy, and then we integrate. Fine. So I believe all of you understood this format. See, थोड़ा लेंदी रहता है, बट क्वेश्चन जो बेसिक बनाए जाते हैं इसमें इतना वरीड नहीं होना है. क्वेश्चन आपके बड़े बेसिक होते हैं, इसलिए look at this. I am taking couple of question which came in NDA once. Fine. Look at this. The next problem based on, I have discussed these two forms are dear. इसी दो फॉर्म में ही अब क्वेश्चन अपने बदलते जाएंगे. नेक्स्ट फॉर्म पे आते हैं. In fact, next problem पे we came to know both the form. अपने को डिसाइड करना होता है while looking question in which form it is given. Question is in the which form? See, क्वेश्चन आया हुआ है इधर कि an integrating factor of the differential equation x dy by dx plus y log x is equal to x e to the power x into x to the power minus 1 by 2 log x. फाइन, ये क्वेश्चन है, इसका हमें इंटीग्रेटिंग फैक्टर ढूंढना है. क्वेश्चन केम एन इंटीग्रेटिंग फैक्टर ऑफ दिस डिफरेंशियल इक्वेशन. ऑप्शंस दिए हुए हैं, ठीक है. तो पहले तो डियर अपने को इसको पहले स्टैंडर्ड फॉर्म में लाना होगा. तो इसके लिए सबसे पहले इस x को यहाँ से एलिमिनेट करना है, विच मीन्स वी हैव टू डिवाइड बाई x टू both the sides. So what left? dy by dx. क्वेश्चन क्या है? क्लियर है? इंटीग्रेटिंग फैक्टर ढूंढना है अपने को, सोल्यूशन नहीं चाहिए, इंटीग्रेटिंग फैक्टर केवल बताना है. So first we divided by x to both sides, so this came y log x upon x is equals to x एक कैंसिल हो गया तो e to the power x into x to the power minus 1 by 2 log x. ठीक है. सो ये अपना फॉर्म किधर रिलेट कर रहा है ये? तो ये फॉर्म हमारा दिख रहा है dy by dx plus py equals to q, where p is log x. यहाँ p क्या दिख रहा है डियर? p is log x upon x. ठीक है. और q हमारा ये पूरा टर्म है, बट अपने को चाहिए क्या? इंटीग्रेटिंग फैक्टर. सो इस फॉर्म का इंटीग्रेटिंग फैक्टर, ऑल ऑफ यू नो व्हाट इज इंटीग्रेटिंग फैक्टर ऑफ दिस फॉर्म? दिस इज e to the power p dx, इंटीग्रल p dx. सो इंटीग्रेटिंग फैक्टर ऑफ दिस e to the power इंटीग्रल log x अपॉन x dx. ठीक है. अब आप इस इंटीग्रेशन को इंटीग्रेट कर लें. सी log x t पुट करते हैं तो 1 by x dx मिल रहा है, यानी मैं कह सकता हूँ कि e to the power log x को आपने अगर t लिया तो 1 by x dx मिल रहा है, यानी t dt. और t dt का इंटीग्रेशन क्या होगा? t स्क्वायर बाई 2, और t हमने log x लिया है तो ये हो जाएगा e to the power log x स्क्वायर बाई 2. सो फाइनली इंटीग्रेटिंग फैक्टर में क्या लिख सकता हूँ? e to the power x, सॉरी ये e to our log x नहीं है, e to our log x बाई log x होल स्क्वायर बाई 2 है, तो ये इतना ही रह जाएगा. इसको आप ऐसे लिख सकते हैं e to the power, इसको एक और मॉडिफाई कर सकते हैं आप. ये 1 बाई 2 दिख रहा है तो आप रूट e भी लिख सकते हो, रूट e to the power, क्योंकि ऑप्शन इस तरह से ही डिज़ाइन है, log x का होल स्क्वायर. या फिर आप ऐसे भी छोड़ दिए, ऑप्शन जैसे मेंशन किया है, e to the power log x होल स्क्वायर बाई 2. एनीवन, जैसे भी ऑप्शन में मैच करना है. सो आई बिलीव यू अंडरस्टूड how to get the integrating factor of this equation. First we eliminate this coefficient of dy dx, so we have to divide by x. This situation came, which is in the form of dy dx plus py equals to q, where p is log x by x and q is as it is as this much total, and we are not bothered about q क्योंकि हमें इंटीग्रेटिंग फैक्टर ही चाहिए केवल. वो हो गया e to the power p dx, है ना. e to the power इंटीग्रल p dx होता है इंटीग्रेटिंग फैक्टर ऑफ दिस फॉर्म. सो log x by x and then we integrated, we took log x as a t, तो 1 by x dx मिला, यानी t dt का हो गया t स्क्वायर बाई 2, फाइन. एंड t स्क्वायर बाई 2, t को हमने वापस log x डाला तो log x स्क्वायर बाई 2, और दिस वे और दिस विल बी द आंसर ऑफ दिस डिफरेंशियल इक्वेशन. इसका इंटीग्रेटिंग फैक्टर ये निकल आया, फाइन. सो ये भी रहता है क्वेश्चन में, इंटीग्रेटिंग फैक्टर भी दे कैन आस्क, और सोल्यूशन तो होता ही है, फाइन. ये मोस्ट ऑफ द टाइम वी हैव सीन द इंटीग्रेटिंग फैक्टर केम मैक्सिमम टाइम. सोल्यूशन भी होते हैं बट इंटीग्रेटिंग फैक्टर का अकरेंस ज़्यादा है. ठीक, आई विल सी next problem in the linear differential equation with constant coefficients. The question it is, this you have to decide whether which form it is. Solution of differential equation they have asked. For equation is dy by dx plus y upon x log x is equals to 1 by x. फाइन. इसका अपने को सोल्यूशन चाहिए, तो अपने को फिर से वो क्या करना पड़ेगा यार, कंपेयर करना पड़ेगा विच फॉर्म में है ये. dx प्लस dy उसके फॉर्म में है, चेक कर लेते हैं. फॉर्म हमारे पास क्या था, dy बाई dx प्लस py इज इक्वल्स टू q. ठीक है, वेयर p एंड q आर फंक्शंस ऑफ x. तो ऐसा रियलाइज हो रहा है कि ये इसी फॉर्म में है, तो p में क्या लिख लूँगा, p इज 1 by x log x, this is p, and what about q, q is 1 by x. ठीक है, p and q confirm. अब कहाँ चलें, इंटीग्रेटिंग फैक्टर. सो फर्स्ट विल हैव टू कैलकुलेट इंटीग्रेटिंग फैक्टर. इस फॉर्म का इंटीग्रेटिंग फैक्टर e टू द पावर p dx होता है. p we have 1 upon x log x into dx. ठीक है, ये हो गया डियर हमारा e टू द पावर p dx. इसको इंटीग्रेट कर लेते हैं. log x को अगर आप t लेते हैं 1 by x dx मिल रहा है, यानी 1 by t मिल रहा है. दैट मीन्स आप अगर 1 by x log x को इंटीग्रेट करोगे रफ में भी जाके, तो आपने क्या करना है, डी एन log x को t पुट करोगे, log x इज t. ठीक है, ये 1 by x dx मिलेगा, तो 1 by t यानी dt by t. So this came log t and t you have taken log x. E to the power log of log x can be write, right? 1 upon x log x का इंटीग्रेशन log of log x है, तो e to power log of log x. इसको आप क्या लिख दोगे, e to the power log x हमारा क्या होता है, x. ये x क्या है, log x है, so log x it will come, right? All of you aware, e to the power log x is x, ये log से होता है. यहाँ पे x हमारा क्या था, log x came. ठीक है, इंटीग्रेटिंग फैक्टर डन. नाउ वी विल गो फॉर सोल्यूशन. इट्स सोल्यूशन. सोल्यूशन के लिए फॉर्मेट है, यहाँ पे क्या आएगा, y इंटू आई एफ. आई एफ क्या है, log x. फिर इंटीग्रल q क्या है, 1 by x इंटू आई एफ क्या है, log x इंटू dx. फाइन. तो अब फिर से आपका इंटीग्रेशन देख लो, ये तो y इंटू लॉग एक्स रह गया इज इक्वल टू log x t पुट करो 1 by x dx, यानी सेम वे ये t स्क्वायर वाला कंसेप्ट आ जाएगा. ठीक है ना, log x by x, log x को t पुट किया तो 1 by x मिल रहा है, तो t स्क्वायर बाई 2 मीन्स, इसको रफ में देख लो आप, इंटीग्रेशन यहाँ पे बेसिक है. log x इक्वल्स टू t लिया तो 1 by x dx मिल गया विच इज dt. सो ये हमारा इंटीग्रेशन क्या हो गया, t dt. t dt क्या होता है, t स्क्वायर बाई 2 एंड t व्हाट वी हैव टेकन, log x. So this is nothing but log x whole square by 2 plus c. ठीक है, this is 2. So this is the solution, y log x equals to log x whole square by 2 plus c of this differential equation. फटाफट गो थ्रू कीजिए. दो जगह छोटे छोटे इंटीग्रेशन है, उसको आप अच्छे से संभालें. यहाँ पे एक 1 by x इंटीग्रेशन ऑफ 1 by x log x, उसको मैंने यहाँ थोड़ा छोटा सब्स्टिट्यूशन करके दिया है. किच दिख रहा है बट आप समझ सकते हैं, बहुत बेसिक इंटीग्रेशन है ये सब. और सेकंड इंटीग्रेशन मैंने फिर यहाँ पे कराया है एक सब्स्टिट्यूशन लेके. ठीक है, जो मैंने यहाँ दिखाया है आपको. क्लियर. तो ये दो छोटे छोटे इंटीग्रेशन आप ध्यान में रखो. सो यू विल गेट अ सोल्यूशन फॉर दिस. गो थ्रू, फटाफट इसको गो थ्रू कीजिए, समझ के लीजिए. This type of sum came in NDA era. So now I am going to take the last problem in this linear differential equation, fine. And this entire differential equation topic में ये पूरी डिफरेंशियल इक्वेशन डन हो गई। 12th में भी डियर इतना ही पढ़ना है जो मैं डिफरेंशियल इक्वेशन के फर्स्ट वीडियो से अब तक के वीडियो में जो दिखाया है, इनके सबके मैंने कुछ कुछ सेगमेंट लेके डिस्कस किया है। अगर आप अच्छे से पूरे वीडियो को देखते हो, फर्स्ट, सेकंड, थर्ड, फोर्थ, फाइव, all this series, you will be able to solve all the problems of differential equation of your textbook or from any reference book. Fine. So now I am taking one last problem of this linear differential equation with constant coefficients. ठीक है, इसमें कभी कभी वर्ड प्रॉब्लम टाइप में भी क्वेश्चन दिए जाते हैं। उस तरह के क्वेश्चन में एक बार मैं आपको बता दूं वो किस तरह का क्वेश्चन वर्ड में लिखा होता है। फाइंड द डिफरेंशियल इक्वेशन, फाइंड द सॉल्यूशन या फाइंड द इक्वेशन। ठीक है, जस्ट चेकिंग वेदर दैट सम वी हैव और नॉट, तो दैट्स वो वर्ड में रहेगा और आप उसके सॉल्यूशन को निकाल सकते हो। ठीक है, जैसे एक क्वेश्चन मैं लिख रहा हूँ, लुक एट दिस। आपके टेक्स्ट बुक में भी वर्ड प्रॉब्लम है, हाँ, वो भी आप देख सकते हैं। वर्ड प्रॉब्लम को इक्वेशन बनाइए और सॉल्यूशन निकालिए। सो दिस विल बी द योर लास्ट प्रॉब्लम ऑफ लीनियर डिफरेंशियल इक्वेशन और टुडेज सेशन का। क्वेश्चन इज व्हाट इज द इक्वेशन, सी व्हाट इज द इक्वेशन ऑफ द कर्व whose slope at any point, whose slope at any point is equal to 2x and which passes through the origin, which passes through the origin. So what we have to find? Equation of curve, यानी वो y चाहिए अपने को। जनरली आप कर्व को कैसे रिप्रेजेंट करते हैं? y इक्वल्स टू एक्स स्क्वायर प्लस 2, y इक्वल्स टू साइन एक्स एंड ऑल। ठीक है, सेकेंड पार्ट मीन्स क्वेश्चन में क्या चाहिए अपने को? इक्वेशन ऑफ द कर्व। What is given in the question? Slope at any point is equal to 2x. Means according to question, what it is provided? dy by dx. Slope क्या होता है? अगर y अगर कोई कर्व है तो उसका स्लोप dy dx, which is given here 2x. ठीक है, ये 2x दिया हुआ है अकॉर्डिंग टू क्वेश्चन। अब मुझे इससे y चाहिए, तो आप क्या करेंगे? वेरिएबल सेपरेबल, dy यहाँ लिया आपने, 2x dx, करेक्ट, इंटीग्रेट करेंगे आप, वेरिएबल सेपरेबल है। सो dy इज y, 2 कांस्टेंट और x का इंटीग्रेशन एक्स स्क्वायर बाई 2 प्लस सी के। सो फाइनली y इक्वल्स टू एक्स स्क्वायर प्लस सी। नाउ थर्ड स्टेप में प्रॉब्लम में क्या लिखी हुई है? विच पासेस थ्रू द ओरिजिन। नाउ ये c जो है अब हमारा वो वैल्यू कैलकुलेट करेगा। ये कर्व जो हमें सॉल्यूशन के बाद मिला, दिस कर्व पासेस थ्रू ओरिजिन, सो इट विल सेटिस्फाई द पॉइंट। सो 0 इक्वल्स टू 0 स्क्वायर प्लस सी, तो अपने को सी क्या आ गया? 0। सो देयरफॉर व्हाट इज गोइंग टू बी इक्वेशन ऑफ कर्व? इक्वेशन ऑफ कर्व विल बी इज y इक्वल्स टू एक्स स्क्वायर एज c is 0, तो क्या कर्व आ गया? y इक्वल्स टू एक्स स्क्वायर। ठीक है, ये ऑप्शन में दिया रहेगा। तो आप समझ गए, ये अकॉर्डिंग वर्ड प्रॉब्लम में भी आप इस तरह के प्रॉब्लम कर सकते हैं। गो थ्रू दिस प्रॉब्लम डेयर। सो for all of you, thank you very much for last 4 months especially all the students, not especially, we can say all of you is, with me, sharing your confusion, sharing your doubts. I'm very happy. Most of the students, they had shared a lot of doubts with me personally or in our NDA platform. So it's a good one. Down the line also the same thing, because till this corona is there, so this medium is on the only medium where we can talk to each other, or we can ask questions to each other. Fine. So thank you very much all of you, and keep patience. Always try to find the solution of any problem. What we say generally, go for solution rather than problem. So always in a asking mode. Lot of things are there what we expect from a trainer. I'm expecting trainer expects from the student that all of you are well versed what we have trained you. So for this you require a lot of practice, patience, confidence, correct? So there are a lot of ingredients which makes you the perfect. And once you are going India's, the quickest exam, which is NDA, where you require your smart approach. You have to be very smart to, choose the question, solve the question. So I believe a lot of students, they are doing for last 4 months this NDA mathematics in all the area. Like Sangamesh sir is also taught you. Their segment is also very interesting. Do problems from those topic also, 2D, 3D, vectors, correct? So all the segments in entire mathematics is interesting, as well as the scoring. The question is your approach, where you are very confident, where you feel that you have not understood, that you can ask to the concerned teacher, so that they will explain you, they will introduce that topic twice again. So I believe still we have another 1 week. So go through entire portion, and in this training I believe I did around, including your homework and all, probably 2000 problems. I think so. If all of most of the students, they tried homework also. So 2000 and 2500 sums if you have done. Now the time came to recap all those problems, all those homeworks which we had given you. Go through those questions, look at their crux part. What should be, you have to remember formulas, trigonometric formulas, calculus के result भी याद रखिए. So there are a lot of things, and be patient. Don't get nervous, don't get confused. This is the time. This coming 1 week is very important to all of yours, correct? So in this time, be confident, plan yourself, and smart approach is required. फाइन डियर, अब इससे ज़्यादा भाषण तो मैं नहीं दूंगा. सामने होते तो मैं दे भी देता भाषण आप लोगों को. खैर इस मीडियम से भी मैंने दे ही दिया है. सभी लोग आजकल आपको भाषण ही दे रहे होंगे, सभी टीचर, पेरेंट्स, फ्रेंड्स. ठीक है, एवरी सबकी बात सुनिए और अच्छे से पढ़ाई कीजिए. यही हमारी बेस्ट विशेज़ है टू ऑल ऑफ यू. मेरे ख्याल से टेस्ट के बाद 1-2 क्लासेस और होंगे. सो देयर आई फील कि मैं डाउट सेशन ही रखूँगा, डाउट्स ही हम करेंगे. ठीक है. सो मीन वाइल कम आई प्रॉब्ली यू हैव अ टेस्ट ऑल्सो. सो प्रिपेयर द टेस्ट एंड डू द बेस्ट देयर. थैंक यू वेरी मच. मैं अभी आज का सेशन यहीं कंक्लूड कर रहा हूँ. गो थ्रू दीज वीडियोज़ देयर. पूरे वीडियोज़ को देखिए. डिफरेंशियल इक्वेशन टेक्स्ट बुक सबसे आप कंसल्ट कीजिए, रेफरेंस बुक. ठीक है. चलिए, थैंक यू.